All right, this is block 4 of topic 6. This is really the last lesson of topic 4, and tomorrow you'll be doing your study guide and then you'll have a test on Thursday. So in this lesson, you're going to be able to understand the implications of the parallel postulate that we've learned and develop a proof on the construction of parallel lines. And really we're going to just focus on the construction and not so much the proof on that. But before we get started, we're going to kind of review what we've learned so far in topic 6. So if you'll remember, in topic 6 we learned what's called the parallel postulate. So that's at the top of your notes here. And we know that any line that is given to us has infinitely number lines that is parallel to it. But once you want to go through a specific point and be parallel to the given line, there's only going to exist one line through that specific point that's parallel to the given line. And that's what the parallel postulate says. So we also learned a related theorem that has to do with perpendicular lines. And likewise, if you're given a line, then there's infinitely many lines that would be perpendicular to it. But if you have to go through a specific point and be perpendicular to the given line, then there's only one line that will do that. We learned some new terms possibly, or just a review of some terms that you learned before, and these are special angle pairs that we learned are created when you have two lines that are cut by a transversal. So remember, a transversal is just a line that intersects two or more lines. So all of these in your figure, line T is a transversal because it's intersecting lines J and K. So one of the new angle pairs that we talked about are alternate exterior angles. And remember, alternate means they have to be on opposite sides of the transversal. So you can see angle 2 is to the right of that line and angle 7 is to the left. Exterior means they have to be outside of the other two lines. So 2 is above that line, 7 is below that line. So these are called alternate exterior. Alternate interior are still on opposite sides of the transversal, but now the interior tells you they are inside those two lines. So 4 and 5 are inside the lines J and K. Corresponding angles are angles that have to be on the same side of the transversal and on the same side of the other two lines. So angles 2 and 6 are corresponding. They are both to the right of line T, the transversal, and they're both above one of the lines. So 2 is above J and 6 is above K. Consecutive, remember, is just another way of saying same side. Interior, meaning they're on the same side of the transversal. They're both to the right of the transversal, angles 4 and 6 are. And interior, meaning they're inside those two lines L and M. Now we learned that those special angle pairs have special relationships once we know these two lines are parallel. So we still have corresponding and alternate interior and alternate exterior and consecutive interior if you don't have parallel lines. It's just they wouldn't have these special relationships. So if you have parallel lines that are cut by a transversal, we learned that the corresponding angles are congruent. So in this drawing, we knew that angles 2 and 6 are congruent. 4 and 8 are congruent, 1 and 5 are congruent, and 3 and 7 are congruent, because those are all pairs of corresponding angles. We also learned that alternate interior angles are congruent. So we have 3 and 6 that are alternate interior and would be congruent, and 4 and 5 that are alternate interior and congruent. We learned alternate exterior angles are also congruent, so 1 and 8 and 2 and 7 would be those pairs. And finally, we learned that consecutive interior are not congruent. They are supplementary, meaning they add to be 180 degrees. So that would be like angles 4 and 6 and 3 and 5. So one thing to note when you have parallel lines cut by a transversal is that typically, unless the transversal is perpendicular to the parallel lines, you will have an obtuse angle and an acute angle. And so all of the obtuse angles will be congruent to each other. So angles 1, 4, 5, and 8 are all obtuse, and so they are all going to have the same exact angle measure. The acute angles will also be congruent. So 2, 3, 6, and 7 would all be congruent to each other. Now again, this is only when the lines are parallel. And so the obtuse angle and the acute angle together would have to add to be 180. And you can see this because 1 and 2 are a linear pair. We know that means they have to be supplementary. So same side interior, if you'll look at that, angle 4 is obtuse, angle 6 is acute. So of course we wouldn't say that they're congruent to each other. That is the relationship that they have, is that they're supplementary. They add to be 180 degrees. The converses of the theorems are also true, and that helps us prove whether lines are parallel or not. So if I knew angles 2 and 6 were congruent, then I could use that to say, well, then I know that means these lines are parallel. Same thing, if the alternate interior angles like 3 and 6 were congruent, that tells me the lines are parallel. If the alternate exterior angles like 1 and 8 are congruent, then that means lines J and K are parallel. And if I know the consecutive angles or consecutive interior angles are supplementary, like if I knew 4 and 6 added to be 180, then that would tell me lines J and K are parallel as well. So those are 4 ways that we can prove lines are parallel. Finally, we used our algebra skills and talked about slopes of lines to come up with 2 very important conclusions. One was that the slopes of parallel lines are equal. So if you ever have equations of lines that have the same number in front of x, which we know is that represents the slope, then we know those lines are parallel to each other. We learned that with perpendicular lines, the slopes are not the same. They are opposite reciprocals of one another. So that's 2 changes. A sign change, that's what opposite means, and a flipping of the fraction, that's what reciprocal means. So they are opposite reciprocals. And that means if you multiply the 2 slopes together, your product will always be -1. So in this case, 2 times -1/2 would equal -1. All right, so we're going to get started on our constructions today. That will be the main focus of today's lesson. So like I said, we're not going to really focus on the proof side of this. I'll kind of talk about why this construction works as I go through it, which is what is used in the proof, but I want to focus on the actual construction itself. So what we want to learn how to do is how to copy an angle. So not get our patty paper and trace it and copy it that way, but to use our compass. Remember, that's what you use with a construction. So you'll need your compass for this lesson. If you need to pause the video and get that out, then do so now. So when I'm copying an angle, I want angle J to be copied down here at vertex K. So I want it to have the same exact measure, and I'm not using a protractor to do that. So I'm going to start off by putting the point of my compass, which remember is that gold hole, on top of point J. And I'm going to choose any setting on the compass. It really doesn't matter. I just want to draw an arc that goes through both sides of that angle. So I'm just going to choose that second hole on the top, and I have gone through both sides of my angle. So you have to remember what setting you used there. So again, I was using that second, there's one really close there, so that second hole, because I'm going to use that same exact setting down here at point K. And so by doing so, I am creating those congruent distances, and I'm just going to keep going for a while because remember, I'm trying to copy this angle, so I know I need to come out here quite a ways in order to do that. So that means that if I label this point right here, where that first arc intersected angle J as A, and the second point where it intersected here as B, and then I'm going to come down here, and since that starts with K, I'm going to start this one with L maybe. So I know that K to L is the same distance as J to A was, because I used the same setting on my compass to create that. So I've got to find out where is the point going to be on this arc that I can connect to K so that I have the same angle created that I started with angle J. And so to do that, we measure with our compass, but not with the ruler measurements on the side. Remember, measuring with your compass means to put your hole setting on one point and find a hole that matches up with the other point. So this is what we're going to be measuring with our compass, hole to hole. So I'm going to put my hole on point A, and then I'm going to find the best hole setting here that will match up with point B here. And it happens to be the 1, 2, 3, 4, 5, 6, 7th hole on my bottom part of my compass there. So as you can see, point A is in this hole, point B is in that 7th hole right there. So once you have measured that with your compass, you're going to come down here to your new angle and put the hole setting on L, and you're going to find that 7th hole again if you did the same as me, and you're going to make an arc that goes through the one that you created the first time. And that allows me to know where that point is that I need to connect with K to copy that angle. So I'm going to label this as point M. So all I need to do to finish this is just connect point K through point M to copy that angle. And so if you were to use your protractor, you would hope that this angle measure here is the same as this angle measure here, because we were copying the angle with that proof. And so this construction takes 3 arcs. You have to make an arc on the angle given to you and repeat it down here on your new angle. So that's the first 2 arcs. And then you have to measure with your compass here and use that to make this arc here. So that's your 3rd arc. So copying an angle takes 3 arcs. So you can practice on your own here, copying this angle over here on this segment here. And you can pause your video to try to do that on your own, and then you can restart it to see it done again if you need that. All right, so I'll just go through that process one more time in case you need to see that. If you don't, you can fast forward through this part to get down to the construction of parallel lines on number 3. So to copy angle H, I'm going to put my hole setting on H and choose a setting. And remember, you have to remember which one it is. So I would count 1, 2, 3, 4, 5. I'm going to use the 5th hole, and I'm going to draw an arc that goes through both sides of my angle. Remember not to go back and forth with arcs. You just want one crisp arc in that process. I'm going to label these points A and B just to have something to name them. And remember which hole you used. Remember it was the 5th hole. So I'm going to come over here and put my hole setting on I, and I'm going to use that 5th hole again to draw an arc. I'm going to start below the line. It goes through that line and go up quite a ways because I know where I want to be. I need to create this line here. So don't stop short with that first arc. So there's 2 arcs. I know I just have one more to do, and to figure out what arc to use, I've got to measure from A to B using my compass, not a ruler. So hole on A and find a hole setting that matches with B. And it looks like it's this 1, 2, 3, 4th hole on the top. There's A, there's B. So I'm going to come over here and put my hole setting on this point. I didn't label it, but let's label it point J. Put my hole setting on J, and I'm going to use that, what was it? I already forgot. I think it was the 4th hole. Is that right? I can't hear you. Talk louder. Yes, it's the 4th hole. All right, so I'm going to put this hole setting on J, and I'm going to count out 1, 2, 3, 4, and I'm going to draw an arc that goes through the one that I already had. So I'm going to label that point K, and now all I have to do is just connect it to I, and I have copied that angle with a construction. And so again, you could use your protractor to see how well you did on copying that angle. All right, on number 3, we're going to use that construction to help us construct a parallel line, but I'll have to start that on the next video because I'm pretty sure that 55 seconds is not enough time for me to do that in.